Hello, these are the video solutions for the Math 1 Chapter 8 test. This is the test that was administered in the spring of 2016. So if you're looking at this video way past this, it's probably a good review for the same chapter. Of course, the questions always change, but the ideas are the same. So question 1 asks us to solve a system of equations, and there were two of them, part A and part B. This is, you can use basically any method that you would like. There's so many different ways that you could approach this first problem, and I think one of the things that I like to think about is why not try them all, right? Why not try a lot of different things? Because if you were to try to solve this system using the equal values method or substitution or rearranging it and then using elimination, you would be practicing all of those critical skills and really ensuring to yourself and demonstrating to yourself that you understand this in a deep way and that you're very proficient with all of those skills. So when I do this problem now, realize I'm just picking one of a multitude of paths, and I'll get a solution, and the solution will be correct because when I check it, I can demonstrate that it does exactly what the system should do. I'll get x and y values that behave exactly the way these two equations say they should behave. So having said all that, let's pick a method to start with here. I think that what I'm going to do is substitution, and at some point I'll use something that we call fraction busters as well. But if I look at the second equation, it gives me this substitution for y, right? Y is equivalent to 5/4 x plus 3. And what my plan is, I'm going to take the first equation, I'm going to plug that value in for y into that first equation. So let's rewrite the first equation. So the first equation is x plus y equals 6. I'm going to write x plus, and then instead of y, I'm going to use 5/4 x plus 3, and that equals a negative 6. So if you look at it, you can see I've got the x and I've got the equals and the negative 6, and then playing the role of y, I have 5/4 x plus 3, which is exactly what the second equation told me y was equivalent to. Now in that step, I've eliminated any references to y in this new equation that I've built. And to clean this up, this is optional, but I don't like dealing with fractions. I think it's easier, more straightforward to get rid of them. So I'm going to multiply both sides of this equation by the number 4, and I've picked this value because it is exactly what's needed to neutralize this particular denominator I have, right? You can see it's 5/4 x. So I'm going to multiply every single term on both sides by the number 4. On the left hand side, I end up getting a 4x, and then when I multiply this next term by 4, it ends up just becoming a 5x, and then plus 12, that's 3 times 4. And then that equals negative 24 over on the right hand side. At this point, I'm going to collapse these two like terms to 9x plus 12 equals negative 24. And then I'm going to go ahead and subtract 12 from both sides. So 9x will equal a negative 36. And finally, as the final step here, I'm going to divide both sides by 9. And when I divide both sides by 9, I get that x must be the number negative 4. Now, this is what I believe x is, and I'm going to move forward and figure out what y is, and then I'm going to check this solution. And if it doesn't check, that means that there has to be an error somewhere in these steps. So I'm going to pick the second equation that we had at the top here. I'll circle this in blue. I'm going to use this now to figure out what y is. I do know what x is because I just figured it out, so it'll be easy to figure out what y is. Y should be equal to 5/4 times negative 4 plus 3. And when I multiply 5/4 times negative 4, I end up getting a negative 5. So y is equal to negative 5 plus 3, so y equals negative 2. So I believe I have my x and y's. And I'm going to go ahead and write that as an ordered pair. I think my solution is x is negative 4 and y is negative 2. But I want to check that against my original equation. Equations, both of them. I'll clean these up so I can look at them here. So if I plug them in to the first equation, right, x is negative 4 and then negative 4, and then plus a negative 2. Well, that's exactly negative 6. So definitely this point satisfies the first equation. And if I plug this point into the second equation, you can see 5/4 times negative 4 produces a 5, and 5 plus 3 is indeed negative 2. So it definitely makes both sides of this equation negative 2. So that's the solution for part A. Part B, in some ways it's an easier system to solve, but in some ways it was problematic for some of us in class because you end up getting this statement that made many of you feel uneasy. So let's take a look at it. I'm going to choose to solve this one using the elimination method. I'm going to multiply this second equation through by the number 8. So both sides, all terms on both sides are going to get a new factor of 8. When I do that, just for convenience, I'll go ahead and rewrite the first equation. It's 3x plus 8y equals 24. And now that I think about it, I actually should be multiplying by a negative 8. So that my y terms will cancel out when I do the elimination process. So if I distribute this through, I have a negative, I don't know why I'm using black there. When I multiply by negative 8, I get negative 40 times x, and I get, I don't need a negative 8. This is already negative. I'm not thinking about this very well. So I'm going to go back to multiplying just by 8, and many of you are probably screaming at me at your home saying, no, you don't need it. So now if I distribute through the 8, I have 40x, and then it is a minus 8y, my mistake. And on the other side it equals negative 24. Now when I combine these, over on the right hand side I get 24 and negative 24, which makes 0. When I add 8y and negative 8y, that makes 0 also, right? And I can put a 0 there if I want, plus 0. And then over here, this is 43x. So if I'm solving this equation, I think this is where many of you are like, oh, there's no solution. Well, there is a solution. If you multiply 43 times 0, you get 0. If you divide both sides by 43, right, we get that x must be 0 divided by 43 is 0. So x is 0. And then if I plug that into either one of the original equations, I can figure out what y is. So in fact, let's plug that into this first equation. That would be 3 times 0 is just plain old 0. And then plus 8y equals 24. So I have 8y is 24. And if I divide both sides by 8, we get that y has to be the number 3. So I think our solution is x is 0, y is 3. 3 times 8 is 24, and then if I plug a 3 into here, this becomes the opposite of 3, or negative 3. You can see on the other side it's negative 3. So this solution definitely satisfies both of those points. So x is 0, oops, ordered pair, x is 0 and y is 3.